Okay, I'm ready. Can you hear me? Raise your hand. Yes, and hear me because I can't. Okay, excellent. All right. Again, my name is Ben Cruz, and I'm from Detroit, Michigan area, and I'm director for the Center of Automotive Technology. And I'll give you a brief little background first. I actually started my career a long time ago, actually. First, I went to high school and I studied, just the general basic stuff and did take some automotive classes. And then I went to a central Arizona community college and spent a couple of years there. And then I actually started working for General Motors. And from that standpoint, then I started basically taking classes. Obviously, GM was paying for them, and continuing in the engineering education area. Went to Arizona State University, and then from Arizona State University, I went to University of Phoenix in Arizona, and I got my master's there. I continued obviously with GM the rest of my life, and in fact just recently retired. When I retired, I had the opportunity to join Macomb Community College and the Center of Automotive Technology. I happened to know the individual who was director prior to me, and the reason I knew him is because in the area that I worked at GM, I actually had um, I actually had responsibility for laboratories, and in those laboratories, we had a need for a variety of technicians. And in talking to Bob, we tried to get some programs so that we could provide higher skilled technicians into the automotive area. My history with General Motors is actually quite varied. I started in Arizona, got transferred to Michigan. From Michigan, got transferred to Mexico. Did some work in Mexico. Also did quite a bit of work in Nashua, Canada. In Nashua, Canada, I built a facility similar to the facility that we built here in Detroit metro area. Like I said, I was responsible for laboratories, but the laboratory is actually quite unique in that it's a series of climatic wind tunnels. It's actually four different tunnels, and the climatic wind tunnels have the capability of doing a lot of simulation type activity and work. A lot of the initial sensor development work for ADAS systems, we actually did a lot of the testing in the tunnels. The tunnels themselves, have the ability to do varied climatic conditions in them, from snow to rain to hurricane winds to you name it, you can do that kind of stuff in there. And so we had the perfect opportunity to be able to do a lot of sensor development in that realm until obviously they got released into some of those vehicles. So anyway, a brief history about me, and we'll go on with the presentation. And I first want to mention that we have some primary sensors that are used by almost all of the ADS systems, all of the OEMs, and those sensors include cameras, radar, LiDAR, and ultrasound. Those are the most common and the most used. That's not to say that there aren't any other sensors involved, because there are, but those are the most used sensors. And what I want to do is basically give you a little brief overview of how those sensors, what those sensors are, and how they work on an autonomous vehicle. And then later on in the presentation, I'll cover radar and ultrasound a little bit deeper. And I want to cover those a little bit deeper because they happen to be the most common and the most used, and the highest market volume, than any other sensor at this point in time. So what are the major ADAS systems? If you take a look at this list here, the ones at the bottom of the list are actually those items that are driver monitoring, driver warning, and basically, and the reason for that is obviously to prevent accidents. As you go up to the top of the list, they are systems that are active safety systems and actively engage in intervening, to prevent accidents. And take a look at the very top of the first list there, autonomous emergency braking. That obviously is activated when a collision is imminent or could possibly happen. Adaptive cruise control is basically just a system that does a lot of adjustment, to maintain vehicle speeds and vehicle distance between vehicles. Forward collision warning, again, is an obstacle detection system, and basically on a screen it'll warn you if there's an issue. And some of the vehicles are to the point where actually they can actually take maneuver to avoid a collision if necessary. Lane departure warning, again, the idea here is to provide warning to the driver, but again, some of the most advanced vehicles can already take active action and keep you in the lane, or at least nudge you towards the center of the lane. Then we've got parking assist. Parking assist is actually quite advanced. And, that's one of the first systems that actually went wide into a lot of the vehicles. Well, a lot of the OEMs currently have those systems. Some of the systems were initially just for the high dollar vehicles, but now you can find them in almost every single vehicle. And the parking assist is actually quite a very good system, to assist you to parallel park, forward park, rearward park, and it's very effective at doing what it does. The latest systems can actually go into a parking lot and even help you find a parking spot and then help you park into that particular parking area. Blind spot monitoring. This is basically to make sure that when you're going to change lanes, that you can actually see if there are any vehicles, obstacles, or whatever to the sides of you in the areas where you can't really see. And they can even nudge you, to make sure that you don't make that lane change maneuver, when there's an obstacle or a vehicle in the way there. Rear cross traffic alert. Obviously, this is, if you're backing up and you're going to go across traffic, it gives you some alerts. So basically, from this point down here, they're basically just alerts, just to make sure that the driver is aware of any issue or problem. Then we've got night vision and pedestrian recognition. And here they use IR. And what they try to do is make sure that we are able to see during the twilight hours at night, and then obviously able to recognize when there's an obstacle and or especially a pedestrian in the way. Traffic sign recognition, and this is able to read the signs, and it's able to obviously see the lights, stop lights and stuff like that. It's able to recognize all of that. It is run by cameras. Then we've got high beam assist, which is basically auto dimming of the lights, to oncoming traffic. And then we've got 360 surround view, and that's the ability to see your car, from a 360 perspective, to see what's all around you before you actually, start your drive-in maneuver event. And then driver monitoring. One of the things that some of the vehicles have, is when you've got it in autonomous mode or semi-autonomous mode, the vehicles at this point in time actually monitor your eyes, make sure that you are actually looking at the roads, that you don't fall asleep and or not paying attention to anything that's going on with the vehicle, and you get yourself into an accident. So basically, the vehicle will actually nod you to wake up and to respond to make sure that you're paying attention to the road system. So that's basically the major ADAS systems. And again, the primary sensors are LiDAR, radar, ultrasound, and cameras. This is one of the brand new Cadillacs. It's actually a Super Cruise. And the Super Cruise, in terms of GM, is probably the most advanced vehicle, well, with the exception of the prototypes that are currently running. But from a production standpoint, this is the most advanced vehicle that they currently have released. And with this vehicle, you can actually drive on many roads that have been pre-mapped, and you can drive totally without hands. But again, this particular vehicle is actually like Chris was saying, above a level 2, but it's classified a level 2 because you still require driver intervention. You still require the driver to be there alert, to be able to take over the vehicle if an issue comes up. So that's what this vehicle does. And basically, the cameras are aimed at your eyes, and if the vehicle sees you, that you're not paying attention, that you've got you don't have the focus, for driving, it'll actually prompt you to get in the game. And if you don't get in the game, it can actually just first, completely cut off the system, autonomous system. And if you still don't respond, it actually can pull to the side and turn off the vehicle, do a safe stop. These are the roads that have actually been mapped for GM, for Cadillac. If you take a look at the ones that look kind of purplish, those were the original mapped miles. that were done in 2017, 2018, when the first Super Cruise came out. Since that time, the Super Cruise has actually had, some enhancements, and also they've extended the range or the number of roads that you can actually drive throughout the U.S. without your hands on the vehicle. Right now, they're up to about 200,000 miles. And basically, what they did is they use LiDAR and they use mapping, GPS, uh, well, primarily mapping, GPS and also LiDAR, to basically, go out and map all of the roads. And they say that they've got, super good accuracy, down to 5 centimeters. So that's excellent for a vehicle, a production type vehicle. So in any of these roads, you do have the ability to drive without actually driving the vehicle, without actually having your hands on the vehicle. Now, GM does not have the highest level of vehicle in current production. This is a vehicle that's actually advertised in Europe. It's an Audi, and its capabilities are supposedly level 3. And with a level 3 capability, you basically don't have to pay attention to the vehicle most of the time. Occasionally, if there's an issue, where the vehicle finds itself at a loss, for whatever reason, it does provide warnings, but you're not expected to be paying attention to most of the road at this level. How well it works, it's hard to say. The vehicle is not for sale in the US. It's only for sale in Europe at this point in time. This is Waymo. And Waymo is kind of interesting. They don't produce any vehicles. They primarily use Chrysler Pacifica vehicle vans. But they do have, again, from a prototype perspective, they do have a level 4 vehicle. And actually, there was an announcement just last week that says that you will have taxi hailing service, from these vehicles, and they will arrive without a driver in Phoenix, Arizona, the Phoenix metro area of Arizona, and that's starting this week. The other one that's doing that is actually Cruz Automation. However, they are currently not actually providing a taxi service, but they do have a lot of prototype vehicles running in San Francisco, California, and they are basically at the same level, level 4. And they just today got permission to go ahead and drive those vehicles driverless going forward, to accumulate obviously additional experience and mileage. There's only one true 5-level vehicle, so they claim it's not really a passenger vehicle. As you can see that, it's more like a drone. And the Kroger grocery store chain and Neuro actually joined together to put together this vehicle. And the idea is to basically to have it be a delivery vehicle. So basically, you put your order into the store. Someone packs the vehicle at the grocery store, sends the vehicle to your house, and you unload the grocery stores, and then it goes back to the store. And it's a pretty cool idea. Obviously, there are quite a few limitations. They only run a specific path, a specific mapped area, and typically just in your neighborhood. A store has a geographical area that they can deliver to, and they're doing this quite regularly currently in Arizona. And in fact, last year, actually, this actually started last year. I think it was in December. I was in Arizona in the Christmas area, and I actually got to see one of those vehicles, cruising the streets as they were making their deliveries, to the different homes, from the grocery store. Okay, so let's talk a little bit about all of the sensors. Not in detail, but basically, just talk a little bit about the primary sensors and where they are. Basically, if you take a look at the colors, everything that's gray, it's basically oh, I can't see the colors right. Strange. But anyway, everything that's gray is camera, and then the longest one here is actually long range radar, and then you've got LiDAR, and then the red ones are actually ultrasound, and then the blue ones are actually additional radar around the vehicle. So as you can see that, there you've got bunch of uh, a whole bunch of sensors, even repetitive sensors in each of the areas. For example, for the ultrasound, you might have as many as 4 or 5 or 6 sensors in there. For the close-in short-range radar, you might have as many as 6 or 7 or 8 on each of the vehicles. So it's quite expensive, to actually put all of the sensors in one of the vehicles. In terms of LiDAR, typically they don't have as many of those systems. And the reason they use the LiDAR is because they actually have, other than the camera, that actually sees what you see, the LiDAR systems is actually the best sensor in terms of perception, in terms of being able to identify, obstacles and what those obstacles are on the road. Unfortunately, LiDAR is extremely expensive. By extremely expensive, I mean like $75,000 per unit is what Waymo started paying for those units. And Waymo said, we're not going to pay that kind of money. What we're going to do is basically develop our own system. So Waymo has developed their own system, and they use LiDAR in their vehicles. And they have just recently announced, like about a month ago, that they would actually start selling their LiDAR systems to other manufacturers, other autonomous vehicle producers. And they will be selling those units at roughly $7,000. So it's still quite expensive when you compare it to, ultrasound sensors and radar. And we're talking in order of magnitude of 10. So they're really expensive. And that's one of the reasons that Elon Musk says those people that use that use LiDAR are doomed. And he says that because it's an extremely expensive system. You cannot have an affordable car if you're going to pay thousands and thousands and thousands of dollars for one sensor. So basically what you have to do is make do with some of the other sensors. And some of the other companies, there are some companies that don't use LiDAR at all. There are some that use a combination of LiDAR and radar, as well as ultrasound. And GM, for example, Chrysler, for example, not Chrysler, GM and Ford, for example, they actually do use the multitude of all of those sensors. And it's a whole bunch of sensors within one vehicle concept. And the interesting thing about that is that the use of all of those sensors, has really driven the market up in sensors. It is predicted that they're going to have roughly 41 billion, that they're going to sell roughly $41 billion worth of sensors by 2025. And that's up from 28 billion sensors that they're selling, 2019 and now. And this is per Polaris market research. Okay, so what are the different kind of sensors and what are their limitations? Different sensors have different characteristics. If you take a look at the camera, it has very good resolution, very good perception, very good identification of objects. And basically what happens, obviously it takes on the visible light that comes into the camera and can classify the objects. The problem with that is that basically cameras see what we see and don't see what we don't see. So that's an issue when you've got fog, snow, smoke, dust, or even heavy rain. Your visibility and your perception goes way down. So that's an issue with the camera. Radar currently comes in two flavors. The long-range radar, which has a range of approximately, has a distance of approximately 200 meters at a 45-degree field of view. And then they've got the short range that typically works really well in the 20 to 50 meter range. Basically with radar, it takes the radar waves that are sent out, reflected, and then received. And basically with that, you can take a look and see where the location is and also calculate what the speed of the object is. Again, radar does work in fog, snow, smoke, darkness, and dust. So that's one of the reasons that it's quite attractive. The problem with radar is that it's not as good as identifying objects on the road. LiDAR range currently is at about 150 meters. It basically sends out an IR invisible pulse. And with that, that is reflected and then received. And that's how that system is able to basically build a picture of whatever object is out in the field of view. And these particular units can also work in the dark, but also have the issue and problem of not working well in fog, snow, smoke, dust, and even heavy rain. Ultrasound obviously can't do what some of these other sensors can do, but they're very good in the very short range, the 2 to 4 meter range. They basically send out ultrasonic waves and basically reflect out of any nearby object. So when you're doing a parking maneuver or a backup maneuver or anything like that, they're ideal because they can actually sense any object, around the vehicle or in the area that you're traveling to or wanting to park. And the good thing about ultrasound is that it works under any ambient condition and works well most of the time. except if there happens to be some material that's sound absorbing material, then you don't get any reflection back and you don't get an actual measurement. But if you have, a soft type material that you might run into, obviously that's not going to cause any damage. But unless it happens to be a person that's totally cloaked in, in something that's that's completely sound absorbing, and you could potentially hit that person. So what is radar? Radar is basically just an acronym for radio detection and ranging, and it's a measurement instrument that effectively measures and finds distance and velocity of any object that's in its path. Radar is not by any terms new. Actually, it was Heinrich Hertz was actually playing with some of these units back in 1880. And he's the person that actually demonstrated the radio waves were reflected by metallic objects. But they really didn't come into use until 1940 when John Randall and Harry Boot actually developed the magnetron. And this made radar a reality. And by the time we entered the World War II, radar was actually effective, for spotting submarines, from the air. And so it was highly used very, very quickly. But in automobiles, it actually took a long time before we actually started using them. And before there was any widespread use, it was basically just 20 years ago. It wasn't that long ago. What radar sensors can do effectively? Radar sensors can determine the distance to an object, that's range, and the velocity of the object. Obviously, that can be calculated. The angle where it is and the angle where it is in respect to some reference. A radar can see through walls, especially wood and sheetrock, can detect glass, can detect a glass wall, a window, door, partition, and can accurately measure the range of any of these objects, obviously relative to a reference. So again, radar can detect objects at a distance and define their speed and their location using radio or microwaves. The technique requires a radio microwave transmitter to send the signals that are then reflected back by the object in the path. The signal is then captured by the receiving antenna and it's processed and to basically determine the properties, the speed, the location of the object. So again, it's just basically a transmitter producing electromagnetic waves, and then taking that data, receiving that data, and analyzing that data, or post-processing that data to give you the properties of the object. According to Continental, the current radar units that are currently out there, and we're talking about the newest systems, 2019, 2020, their current field of view is 45 degrees, and their range is currently 200 meters. So that's pretty good, but still there is a lot of active development going on to basically increase the field of view 60 degrees and also the range up to 300 meters. And again, a radar can operate in varied environments and does not have any moving parts. And the sensors are very cheap or economical compared to other sensors. And it actually has some very good reaction time for vehicles traveling higher speeds in excess of 50 miles per hour. And again, the biggest disadvantage with radar is that the image resolution and detection is not as good. However, Continental is developing some new radar systems that actually can, in fact, take a look and identify varied objects, and can also take a look and see relatively small objects out on the road in their field of view. The use of a radar is also expanded globally. By 2030, it is expected that roughly 65% in the automotive use will be using radar, up to 65% of their vehicles. In the United States, we're a little bit slower, a little bit behind, but still it's expected to, our usage is expected to go up to about 50%. The global automotive market alone is anticipated to reach roughly $15.6 billion by 2026. And then the biggest ADAS system that uses, these sensors is obviously adaptive cruise control. Adaptive cruise control is now being used in almost all of the vehicles. So the market has grown tremendously over the last, 4 or 5 years. Oops, oops. There we go. This is basically just trying to show you where the radar and ultrasonic units are. And all of the blue is basically just radar. The orange is ultrasound, and the yellows are actually cameras. But you can see that you've got a huge variety of, or not a huge variety, but a huge quantity of radar sensors, ultrasonic sensors, and a few camera sensors. A typical ADAS vehicle at this current time. So a little bit about an ultrasonic sensor. Again, it's basically a measurement device that sends out an ultrasonic wave. And that wave is obviously uh, sent out to see if there are any objects out in the field of view. Any object that's out there in the field of view is obviously going to bounce back that signal and send it back to the ultrasonic sensor. And the highest use for ultrasonic sensors are actually in the driver assist mode, and for obvious reasons. The range is relatively short, 20 to 50 meters, and so you can't do a whole lot with that other than for parking. But for parking, obviously, it's working very, very well, and it's actually gaining momentum, and almost all of the vehicles are also getting to the point where they will have this system. This is a little more detail on the ultrasonic sensors and how they work. Yeah, but the important thing here is, how, how are the sensors best used? And they're obviously used to detect presence, to detect level, detect position, and detect distance. Ultrasonic sensors can work independent of light, smoke, dust, color, rain, and any other environment. The only exception is, the exception I mentioned a little bit earlier. If you have sound absorbing material, it is difficult to actually sense that because the materials do not bounce back the signal. Here is a vehicle that's parking. Obviously, this vehicle is actually, this is a video, but I didn't know we were going to have video capability, so I just took a picture. But basically, what the vehicle does is can come down the aisle and find an available spot, and then with the ultrasound sensors, and as I mentioned before, there's a whole bunch of ultrasound sensors on vehicles, and obviously different OEMs put different numbers or quantities of those sensors. But this particular vehicle has, like four in the back and then two in the side and then four in the front and two in the side. And with that, you're able to actually find, the side ones actually are able to find an open spot, an open parking spot. And then between all of them, they're actually able to back the vehicle up squarely, into any parking lot, whether it's head-on, forward, or parallel parking. In case you don't know what the sensors look like, these are the typical sensors that go into the bumper. Typically, you'll see these in a lot of the vehicles in the front fascias or back fascias. You have additional ones that go in the skin of the bumper here. And then these are bumpers that are more used for experiments and for models that you're working with, either Arduino or something else. But again, they're basically just sensors that you can use for a variety of projects. And this is what a basic radar unit looks like. These obviously you don't see because they can be behind fascias, they can be behind panels of a vehicle, and but they work effectively in that fashion, and this is how they mount them in the vehicle. Even though you don't see them, you would have some in those areas, the back and the front, and at times even in the side. And again, the ultrasonic sensor market is booming. The current value of that market is roughly 4.1 billion, and I'm sorry, it's going from a value of 4.1 billion to a value of 12.1 12.1 billion by 2030. So again, the market is really, really growing, and it's just not vehicles alone. They're actually using it, for a lot of the automation that's going on in a lot of the vehicle plants and other plants, not just vehicle plants. And basically, the demand just continues to go up, and autonomous vehicles are driving that. And the autonomous vehicles are not necessarily just cars. They could be medical electronic drones. They could be automotive. They could be oil, gas industries, or anything that it has an autonomous type vehicle. Okay, so when you take a look at all the ADAS systems and you take a look at all of the sensors that you've got working on a vehicle, initially all of the sensors were basically independent units. And by independent units, I mean that each one of them is sensing something and reporting to its ECU in the vehicle, and that reports to a master controller. It's actually quite a difficult process. Initially, there was not a whole lot of fusion going on with that. And as more and more sensors got put into the vehicle, it became more difficult because that's when you got into the big data. And then they started adding high definition maps. Yeah, and then they also started adding the communication links, vehicle to infrastructure, vehicle to people, vehicle to anything else. And the data all of a sudden it was extremely large. So from this point forward, there was a need to have basically sensor fusion. And and basically what they're doing is combining all the sensor inputs, map, GPS, V2X, and then that basically uh, gives you the idea of where I am, what is around me, where do I want to go, and then you've got use sensors inputs with algorithms that produce outputs to control steering, braking, and power. And this is basically to take me where I want to go and take me there safely. And this is basically, again, the major sensors for the major ADAS systems. And the idea is to basically get a multi-domain controller to fuse all of this data that's going in and out into one controller with multiple layers, and to be able to respond much more quickly, to the data, make decisions much more quickly as to what the vehicle is going to do, uh, depending on, the input. Obviously, the advantages of redundant sensor fusion and redundant sensors as well is that the probability of correct detection and classification increases with additional sensors and redundancy. Utilize sensors with highest signal to noise ratio under the ambient conditions. Disregard the sensors that have low noise signal to noise ratios, under some ambient conditions. And that improves the reliability of the system. Adding more sensors increases the reliability to the overall system, and actually increases, the potential, or decreases the potential for, sensor failure or system failure. And finally, I want to talk a little bit about safety, because innovation obviously drives, some of the activities going on. So do economics, but so does what's happening in the road systems. And if you take a look at what NHTSA says in terms of accidents, roughly 1 million days are spent in a hospital each year, due to crashes. 2.5 million people in the US go to the ER, and roughly 200,000 of those per year are hospitalized. And the cost of automobile crashes is roughly 212 billion. So one of the things that the government's obviously pressing for is because, because ADAS vehicles are purportedly going to be much better at controlling the vehicles. There's going to be fewer accidents. And in fact, some of the automotive companies, like for example, GM, one of their goals, one of their visions is to actually get to a point where they will have zero accidents. And anyway, if you can think that the ADAS systems are going to reduce accidents by roughly 90%, you can actually save 180 to 190 billion dollars, to the U.S. economy. And then my final slide, basically, it says that technology can save lives. And again, NHTSA says that 94% of the accidents the crashes are due to human error. And that's what ADAS systems, tend to do, is basically eliminate the human error. Eventually, they may get to the point where they can see and drive even better than a human being, because obviously the fusion of all those sensors, including the vehicle response, is all noted and all recorded and all controlled, uh, by the controllers, and they can respond much quicker and much better than an individual can. And that's it. Any questions?
So I got a question there, Ben. You had talked about
Yes.
LiDAR, and I know a lot of the LiDAR that's being used is mechanical LiDAR, and that's one of the reasons it's so expensive. How's the push going for solid state LiDAR?
There are multiple companies that are currently working, to get to that point. And you're exactly correct when you say that a couple of the issues that we've got is that all those mechanical parts and systems add a lot of cost to the units. But additionally, they add failure rate to those units because you've got all those mechanical systems moving around in different environments. That currently is not, well, actually, it's never been true for radar. They basically don't have all of those moving parts. So the reliability, the cost is substantially lower because of that itself. I would expect that, at the rate that they're currently working on those systems, that probably within a couple of years, we will have that advance. The thing that's currently happening a lot is that, they're taking LiDAR and or radar and basically doing a fusion with cameras, either infrared camera or stereo cameras or any kind of those cameras. And that alone, gives you a greater ability than just your LiDAR system and or your radar system. Um, and LiDAR, one of the biggest problems that they've got is economics. It's always been very, very expensive. But there is a company that just recently introduced, or not introduced, but advertised a unit that is going to be sold sometime in the near future for roughly $500. Now, there's not a whole lot known for on that system yet, but we'll see what happens over the next year or so. Any other question?
I have a question about integrating all the different sensors together. Where are you guys at with that? Is that being done?
That's
Well,
being done as we speak. If you take a look
okay.
at the major OEMs, both Waymo, well, not Waymo, Chrysler. I meant to say Chrysler, but Waymo's the one that's doing the Chrysler stuff. And you take a look at GM, you take a look at Ford, and that's already happened. You take a look at Audi, Mercedes, and that's already happening. They're putting in, controllers that can basically, fuse all of the data and integrate all the data together, so they can have a quicker and faster response, a quicker response, for anything that they need to do in terms of, well, the biggest issue is obviously object definition. So that's the
Yeah.
biggest problem because, if you take radar alone, it doesn't know if there's a deer on the road or if it's a rock in the road, so that's, it's obviously a substantial limitation. But, when you combine it with a camera and you fuse that data together, you're able to see that there's an object there. You know how far the object is. You know if the object is moving, and you can define the object because you've got the camera data in place also.
Yeah, so the technology is out there already to solve the
Oh,
problem that
yes,
the speaker from 2G Robotics was talking about with not being able to see and limited visibility underwater.
correct. Correct. And
Mhm.
obviously, that's the same problem under some environmental conditions on road surfaces. You can't
Mhm.
see, and it's difficult to drive safely. Anything else?
Yeah, I got one more, Ben. Oh, go ahead.
Yes. Oh, I can't hear you. Can somebody repeat the question? I cannot hear.
How does the legalities work with like DWIs and people using them as designated drivers? I'm sure that's going to have to catch up.
Yeah, I could barely hear the question, but I'll try to answer. Obviously, one of the biggest problems to fully autonomous driving is the legalities of everything, because, there's acceptance, there's, how's the insurance going to treat the vehicles, there's all kinds of other related type issues that need to be resolved and laws that need to be placed, to be able to basically weave through all of that in order to have safe vehicles. Now that's being, there's a lot of that already being going on, both at a state level and also a government level, where they take a look at the vehicles and take a look at, everything from a people perspective, to see how they can integrate, obviously, the autonomous vehicles into the road systems. Did I answer your question? I couldn't really hear you real well.
I think you did to an extent. She was asking basically if an autonomous vehicle could be your D.
Oh, I'm sorry. I really couldn't hear you. I was just making up an answer with what I thought I heard. All right. The answer is yes. Of an autonomous vehicle, and in fact, you currently will have that ability starting this week in Arizona. You can actually, call a taxi, call a Waymo taxi, and he can deliver you and take you almost anywhere. And if you're drunk, so what? You're in the back seat. If you've got an issue, of any kind, you're in the back seat. So it's obviously you get around that issue.
So Ben, talking about the last statistic that you had, not on this slide here, but the slide before with the 180 to 190 billion in savings. Now, is that once we get to the level of widespread level 4, using that 5G for vehicles to talk to each other as well? Or where's that threshold start for that 180 to 190 billion dollars in savings?
Well, obviously, to get to that level, you're almost going to have a pretty good saturation of autonomous vehicles. We are not there yet, and we won't be there for a while. However, the incrementation of the savings is already happening. GM put out a report not too long ago, and I don't remember all the details, but they basically specified, they work with the federal government and basically specified, the current savings, due to the autonomous technologies in some of the vehicles, because you can already, save or, save yourself from crashes because you're able to see, things that you weren't able to see in the past. And a simple example is actually the backup camera. You take a look at the backup camera. Almost all of the vehicles currently have those cameras, and you can readily see, where the objects are behind you, and that itself, saves some accidents, and all of the other current ADAS systems, basically do the same thing, like braking, like adaptive cruise control, that basically keep you from having accidents. Also, the lane change assist and the parking assist. So all of those are already working towards helping you with that. Now, obviously, you still have to have a very large saturation of vehicles that have that same capability to be able to reach that maximum level of 190 billion.